Hello students, this is the third video of chapter 6, that is for resonance and formal charge, and the learning objectives of this video is 1. Compute the formal charges for atoms in any Lewis structure. 2. Identify the most reasonable Lewis structure for a given molecule using formal charge. 3. Explain the concepts of resonance and draw Lewis structures representing resonance forms for a given molecule. These are the 3 learning objectives of this video. Let me move to the formal charge. Formal charge is a charge of an atom or an ion in a given molecule, and it helps us to predict the most appropriate Lewis structure when more than one is reasonable. 2. The sum of the formal charges of all atoms in a molecule, that is in a neutral molecule, must be equals to 0, and the sum of the formal charges in an ion should equal to the charge of the ion. And how can we calculate the formal charge? We can calculate the formal charge by using this formula. Formal charge is equal to the valence electron on free atom minus number of non-bonding electron plus half of number of bonding electron. Or you can calculate the formal charge as formal charge is equal to number of valence electron on free atom minus half of number of bonding minus number of lone pair of electrons. By doing this, or by using this formula, we can calculate the formal charge. For example, if you are asked to calculate the formal charge of carbon, chlorine, and oxygen in this compound, how can you calculate? We can use either this formula or either this formula. So to calculate the formal charge for carbon, we know that carbon, the atomic number for carbon is equal to 6, and if you configure the electrons 2, 4, so the formal charge, the valence electron for carbon is equal to 4. 4 minus half of number of bonding. We have number of bonding electrons here, 1, 2, 3, 4 pairs. That is totally 8 electrons minus number of non-bonding electrons as the carbon, or lone pair of electron as the carbon. We don't have null pair of electron as the carbon, so 0, and which is equal to 0. The formal charge for the carbon is equal to 0. Similarly, the formal charge for oxygen is equal to 6. That is oxygen. It has 8 atomic number and is equal to 8 electrons. If you configure 8 electrons, we will get 2, 6. 6 is the valence electron for oxygen. So 6 valence electron minus half of number of bonding electron. We have 1, 2 bonds, that is totally 4 electrons, minus lone pair of electron as the oxygen. We have 1, 2, 3, 4 electrons, which is equal to 0. Similarly for chlorine, for either this or either for this, for each chlorine, formal charge is equal to the valence electron for chlorine is 7. 7 minus half of number of bonding electron. We have 1 bond here, that is 2 electrons, minus number of lone pairs at the chlorine. We have 6 lone pairs here, 3 lone pairs, totally 6 electrons. By computing this, the answer is 0. So the formal charge for chlorine is 0. And another example is formal charge for oxygen in ozone resonance. We have 2 resonance, this resonance and this resonance. I will explain what resonance is in the future. And the formal charge for this oxygen, and oxygen at C. The formal charge for oxygen at A is equal to the valence electron, that is 6 for oxygen, minus number of non-bonding electron at the oxygen at A, that is 4, minus half of the bonding electron for oxygen at A. We have 1, 2 bonds, that is 4 electrons, which is equal to 0. Then, and the formal charge for oxygen at B, that is 6 valence electron minus number of lone pairs at B for oxygen is 2, minus half of number of lone pairs. Number of bonding pairs, that's 1, 2, 3 pairs. Totally 6 electrons, which is equal to plus 1. And oxygen at C, which is equal to valence electron 6 minus number of non-bonding electrons at oxygen at C, that is 6. 1, 2, 3, 4, 5, 6 minus half of number of bonding electrons. Half of bonding electrons, that is what we have one bond and 2 electrons. The answer is -1. Yeah, so in similar way, you can calculate the formal charge for oxygen, for this oxygen in this resonance. And this is our second example. The third example is the formal charge for nitrogen, for carbon, and for oxygen for these 3 resonance. And let me do for the first one, and you can do in similar way. For this resonance, we know that nitrogen has the 7 atomic number and 7 electrons. If you configure 7 electrons, we will get 2 5. So 5 is the valence electron for nitrogen. So formal charge for nitrogen is equal to 5 valence electrons minus non-bonding electron at the nitrogen. We have 6 non-bonding electron, that is 3 pairs, minus half of bonding electrons. We have 1 bond, that is 2 electrons. The answer will be -2. And the formal charge for carbon is equals to 4. That's formal charge for the valence electron for carbon is 4 minus the number of lone pairs at the carbon, no lone pairs at the carbon, that's 0, minus half of bonded electrons at the carbon. We have 1 2 3 4 bonds, that is 8 total electrons, and the answer will be 0. For oxygen, we have 6 valence electrons and 6 minus 2, that is lone pair at the oxygen, 2 minus half of the bonding electron. We have 3 pairs of 3 bonds here, total 6 electrons, and the answer will be +1. If you sum up the valence electron, the formal charges for each element, the answer is equals to the charge on the molecule. -2 plus 0 plus 1 is equals to -1. Similarly, you can do for the rest one. This is how to calculate the formal charge. Another thing is identifying the best Lewis structure from the given resonance, and we can see this by 4 cases. The first case is a molecular structure in which all formal charges are 0 is the most preferable. For example, if you consider the resonance for carbon dioxide, we have 3 resonance for the carbon dioxide, this one, and this one. I will explain what resonance in the future. And we have 0 0 0 formal charge here +1 0 and -1, and 0 +2 and -2. So which one is the preferable Lewis structure? And in the case 1, it says that a molecular structure in which all formal charges are 0 is preferable. So this one is the preferable one. This is the first case. The second case is this one. Lewis structures are preferable when the adjacent formal charges are 0 or all or of the opposite sign. If you consider these 3 resonance, this one, and this one, which one is the most preferable? I hope your answer will be this one, because it says that Lewis structures are most preferable when all the adjacent formal charges are 0. So the adjacent formal charge 0 is this one. So this is the most preferable one. And case 3 is a molecular structure with non-zero formal charge. It talks about Lewis structure with non-zero formal charges. If all the formal charges are non-zero, and the arrangement with the smallest non-zero formal charge is preferable. That is the third one. The fourth case is Lewis structures with the negative formal charges on the more electronegative atom is more preferable. Consider these 2 resonances, this one and this one. And which one is the more preferable? I hope your answer will be which one? This one or this one? Which one is the more electronegative? Nitrogen or oxygen? I hope your answer will be oxygen. So the more it says that Lewis structure with the negative formal charge on the more electronegative atom is the most preferable. So oxygen is the more electronegative atom, and oxygen should have minus charge. So this one is the more electronegative. I mean the more preferable Lewis structure. This is the way how to identify the best Lewis structure. Another is the resonance. What is the resonance? Resonance is structures as two or more Lewis structures where only non-bonding electrons, that is lone pair of electron, and double and triple bonds may move around the central atom, and it uses two or more Lewis structures to represent a particular molecule. You can convert one resonance form to another by moving the lone pair to the bonding position and vice versa. Example, let us see this with example. We have 5 examples here. The first one is the resonance for this compound. The resonance for this compound, we have 3 resonances. The first one is this one, and the second one is this one, and the third one is this one. So you can adjust the bondings by moving the pair of electrons. Which one is the more preferable? This one, the first one, A, B, or C? Which one is the most preferable? Can you answer? Yes, I hope your answer will be this one, because this indicates that the negative charge is on the more electronegative, that is oxygen, and we have 0, 0 at adjacent carbon, adjacent molecules. So the most preferable molecule is, or Lewis structure is this one. Example 2 is the Lewis structure for the ozone. We have double bond at this oxygen and at this oxygen, and double bond at this oxygen and at this oxygen. Example 3 is for nitrous. We have 2 resonance, double bond at this oxygen and this nitrogen, and double bond at this oxygen and at this nitrogen. And the third one is, the fourth one is for for nitrate ion. We have 3 resonance and double bond at this oxygen and at this nitrogen, double bond at this oxygen and at this nitrogen, and double bond at this oxygen and at this nitrogen. By calculating the formal charge, you can choose the more preferable Lewis structure, and the last is this one. Carbonate has 3 resonance, 1, 2, 3. This is all about our formal charge and resonance. The next video is about the molecular structure, that is molecular geometry, valence shell electron pair repulsion theory, by using valence shell electron pair repulsion theory. Thank you for watching this video. See you next time.